Everybody, this is Mr. Bells here, and this is your video for Precalc A P-6, and this one deals with imaginary numbers. So just a quick little reference again. Let's say that I had this situation, and I wanted to know when this parabola equals 0. You can see that it doesn't touch the x-axis at all. So from all previous units, we used to just say that that was no solution. But turns out that we actually do have solutions for it. So let's say that we were trying to solve this equation, x squared plus 4 equals 0. Well, if I solved it algebraically, I'd write x squared equals -4. I'd square root both sides, and I'd get x equals plus or minus. And we'd have this situation right here, which is a square root of a negative number. And we know that a negative times a negative is a positive, and a positive times a positive is positive. So trying to find two numbers that multiply together that are identical, that equal a negative, was impossible until we defined this. So we're going to define the square root of a -1 to equal I. Some of you have probably seen that before. But I stands for an imaginary number, and it does have applications all over the place. So we'll also call I a subset of these things called complex numbers, where you can have a real part plus an imaginary part like 3 plus 2i, or 4 minus 6i. And today's lesson, we're going to talk about how do we add, subtract, multiply, and divide these imaginary numbers. Because it is true that right up here, if I took the square root of -4, I could rewrite that as the square root of -1 times the square root of 4, because those two things multiply together to get the square root of -4. And since the square root of -1 is I can then change that to an I, and the square root of 4 is, of course, 2. So my solution right there is plus or minus 2i. And not that I want you to use your calculator right now, but I'm just going to show you right now quickly on this. Bring that down here. That if I put in parentheses 2i and I squared it, you can actually see that it does equal -4. So all the things that exist for our problems in regular numbers are also going to work for imaginary numbers, but they're going to be a little tricky on some of the things, and that's what our lesson is about today: adding, subtracting, dividing these imaginary numbers and where they actually come from, so that we can talk about solutions. So hopefully everybody's good on that. So number one, what if I had 3 plus 2i, this complex number, plus 4 minus 7i. Well, whenever we have addition like this, we're simply going to take the real parts, the 3 and the 4, 7, and the imaginary parts, 2i, and plus and minus 7i. And we get 7 minus 5i. And if you did that on your calculator, it would work that way too. But I wanted you to be able to do all these without the use of your calculator. So number 2, let's try subtraction. And multiplication and division are the hardest ones. So I'm gonna go through these pretty quick. Okay, so 6 minus 3i minus -2 plus 4i. So I'm doing subtraction with these two complex numbers. Well, you know subtraction outside of a set of parentheses, so just kind of push that through. Or you can just kind of write it a long way. So real and real. So 6 minus a -2 minus a -2 becomes plus 2, so that gives me 8. -3 minus 4i should be -7i. And that would be your final answer, 8 minus 7i. So far, so good? Okay, so multiplication. We'll do 4 plus 3i and parentheses 2 minus 5i. Okay, so when I do these things, since there's no addition or subtraction sign in there, and I have two terms times two terms, it's no different than if I had like this, x plus 6 times x minus 2, and I have to FOIL this, right? First, outside, inside, last. Well, I'm going to do the same with this. So real part to real part, 4 times 2 is 8. inside imaginary part is 6i. Outside imaginary part is negative 20i. So negative 20i plus 6i is negative 14i. And then here we go. 3i times negative 5i would be negative 15i squared. And just so we're clear on this, if I equals the square root of negative 1, then if I multiply both sides by I, or if I squared it, right, then I squared must equal, that square kills that square root, negative 1. So that's, if you want to think about trigonometry, that's kind of like an identity. I squared is equal to negative 1. So then I'd have 8 minus 14i. Since this is negative 1 times negative 15 is positive 15. And then real parts and real parts, and I get 23 minus 14i. And that is my final answer mathematically. Okay, so go ahead and try this one on your own. 2 minus 7i and negative 3 plus 2i. So pause the video. Try that one. Okay, so hopefully you did that already, and here's your quick check answer on it. So 2 times negative 3 is negative 6. Inside is 21i, outside is 4i, so that's plus 25i. Negative 7 times positive 2 is negative 14i squared, which becomes positive 14. 14 and negative 6 is 8, so 8 plus 25i. That should be your final answer. Hopefully that's what you got on your thing. Okay, so let's go to one more. Try this one. 3 plus 6i times 3 minus 6i. And go ahead, pause the video again, see what you get. Awesome, so hopefully it looked just like this. 3 times 3 is 9. Inside is 18i, outside is negative 18i, and those things cancel. That's awesome. And then you have 6i times negative 6i, which is negative 36i squared, or plus 36, which equals 45. And this is a really important fact, okay? That it's kind of weird, but if you have a complex number times another complex number, and the imaginary parts are opposites of each other, not the real parts are the same, but if the imaginary parts are opposite of each other, it'll equal a real, okay? And these, when you have 3 plus 6i and 3 minus 6i, these are called complex conjugates. And those are things that help us be able to do division problems. Okay, so again, examples, just so that we're here. 2 plus 4i and 2 minus 4i. Negative 6 plus pi I and negative 6 minus pi I. So these things are called complex conjugates, and whenever you multiply them together, it will equal a real number. The imaginary parts will disappear. So why is that important? Well, that's important because when I do division problems, it's kind of like division was with radicals, and we didn't want to have radicals on the bottom. If I had 3 plus 6i over 2 minus 4i, one of the rules in simplifying division with complex numbers is no imaginaries are allowed on the bottom. So you're like, well, how do I get rid of that? Well, just like with radicals, when I multiply by the same radical, it's going to be really close. I'm simply going to multiply top and bottom by its conjugate, because we just showed in that last series of problems that when you multiply by the conjugate, it equals a real number. So let's go ahead and do this. 2 times 2 is 4. Inside, right, and outside, negative 8i and positive 8i, those should cancel. And then you have negative 16i squared, which is plus 16. And now you can see that your new denominator is 20. Okay? Sorry, move that over for you. Now I got to do the top. So 3 times 2, right? This is multiplication. 3 times 2 is 6. Inside is 12i, outside is 12i, that's plus 24i. And then 6i times 4i is 24i squared, which is minus 24, which gives me negative 18 plus 24i. And of course your calculator won't give you that because it'll reduce a lot of this stuff. So negative 18 plus 24i and 20. So I know that 2 goes into all of these things, right? And that would give me negative 9 plus 12i over 10, or negative 9 tenths plus 12i over 10. And it might even reduce this to 6/5 when it does that. So let's do a little quick check and see what our calculators actually do for us, because I want you to be able to go back and forth between these things. So here on my calculator, I'm going to do parentheses. I've got to do it in parentheses. 3 plus 6 I, parentheses, divided by parentheses 2 minus 4 I, close parentheses. If you don't put these whole things in parentheses, it will definitely not do the math that you wanted it to do. So I hit enter, and you can see that it changes it to a decimal, just like that. However, you guys know if you hit math, and then the first key right here, math frac, and hit enter, now you can see it's negative 9 tenths plus 6/5 I, which is what I said it might do in terms of reducing this. Sweet. Okay. Again, I need you to be able to do this by hand first. I need you to understand how that works out. So again, you could try one of these, but there's lots of them to practice on the thing. So I'm going to go right to one that's a little bit more complicated now. So let's do x squared plus 4x plus 10 equals 0. I'm going to try and solve this equation. So the first thing I try and do is I try and factor it, right? And I'm going to go through a whole process right now, try and factor it. And then I know that factors of 10 are 1 and 10 and 2 and 5. And that since that's plus and that's plus, I have to add these together. So this adds together to 11 and this adds together to 7. Neither one of those add together to 4. So that means that this is not factorable. So I can't do it that way. So if I can't do it that way, I could go ahead and graph it. So let's take a look at my graph right now. So x squared plus 4x plus 10, and zoom 6. Oh, and you can see it, right? Oh, that doesn't touch the x-axis, which means it's not that there's no solutions, it just means there's no real solutions, and we need to figure out the imaginary ones. Surprise, surprise, that's why this problem showed up here. So if I can't do it like that, then there's only 2 ways that I can do it. I can do complete the square, which I need you to get really good at, and the other way is quad formula. Okay, both of these things work for imaginary solutions. We just got to be able to complete the square. Okay, so completing the square. X squared plus 4x equals negative 10. Remember, we move the constant to the other side. Half the linear term, half of 4 is 2. Put it in a little square box. What do we do with the thing in the square box? We square it, and we add that new number to both sides. So there's my plus 4, and there's my plus 4. This thing has now become a perfect square, and it will always factor into x and whatever's in the box times itself, which I usually won't ever write this step, but I think sometimes it helps in the beginning, because I did make a perfect square since those are the same thing. So x plus 2 squared equals negative 6. Good deal. Now I can square root both sides, and I get x plus 2 equals plus or minus the square root of negative 6. And we can rewrite the square root of negative 6 as I times the square root of 6, because the square root of negative 1 is I, and I'm just replacing the negative. So pretty much anytime you have a negative under the radical, you can just replace it with an I in front of the radical. So I square roots of 6. Okay? Minus 2, so x equals negative 2 plus I root 6, and negative 2 minus I root 6. Those are your two solutions right there. Now, here's the funky deal. Here's the funky deal. Guess what? Watch. This is gonna freak you out a little bit. I believe it will. At least I hope it will. So I'm gonna go ahead and turn this on. You guys can see that. I'll focus this in a little bit. So I'm gonna go to my home screen, and I'm gonna actually put that in there. So remember, negative 2 minus I root 6 was one of them. So negative 2 minus I square root of 6. That is supposed to be a solution to my thing. So I'm going to go ahead and hit enter, and I'm going to store that in x. So if that is really a solution to this problem, this x squared, let me go to the original problem right up there, x squared plus 4x plus 10 equals 0, then I should be able to retype that right now, x squared plus 4x plus 10. And since I just stored that as x, when I hit enter, it should equal, say it with me, yep, it should equal 0. Look at that, it definitely does. Cool, so we know that that was a solution to it. I'm going to do the same thing here now. I'm doing it with the quadratic formula. So I'm going to go ahead and write them down. A is equal to 1. B is equal to 4, C is equal to 10. Those are from right here, 1, 4, and 10. The A, B, and C from the original problem. Okay. So negative 4 plus or minus the square root of 16 minus 4 times 1 times 10, like that, all over 2, which gives me negative 4 plus or minus the square root. 16 minus 40 is negative 24, all over 2. And here's where your simplifying radical stuff has to come back into play. So I know that I can rewrite that as this negative 4 plus or minus I square root of 24 over 2. 24 as a square root, I can rewrite it as the square root of 4 times the square root of 6, and the square root of 4 is 2, so I can rewrite it as 2 times the square root of 6. So, following this direction, I get negative 4 plus or minus I times 2 square roots of 6 all over 2. Now this 2 can go into here. I get negative 2 plus or minus. This 2 kills that 2. I root 6. And now you can see that is the same answer as what we got before. Okay? So I'm going to give you one to practice right now. Go ahead and give this a shot and see how it goes. So try here. Try and solve x squared plus, I'm going to keep it easier right now so you can do completing the square without having a fraction. X squared plus 8x plus 14 equals 0. Just to be clear, watch my calculator. X squared plus 8x, x squared plus 8x plus 14. Oh, these ones just have the real ones, so looks like I got to go a little bit higher on this. So let me do it like this. Let me make this a 6. Sorry, x squared plus 6x plus 14, and I think that'll raise it up high enough. 6 graph. There we go. So now that definitely does have imaginary solutions. So go ahead and give this one a shot. So stop the video, pause it, try it, see how it works out for you. I'm going to come back to it in just a moment. Sweet. So hopefully that went great. And we're going to go here. So x squared plus 6x equals negative 14. Half of 6 is 3. Put it in your square box. 3 squared is 9, plus 9 here, plus 9 here. X plus 3 quantity squared equals negative 5. Right? I don't even have to think about this. I just know it's x and whatever's in your box, which was a positive 3, so I put a positive 3. Just got to make sure I add the 9s to both sides there so that I do get negative 5 there. Root it, and I get x plus 3 equals plus or minus I root 5, and x equals negative 3, because when I move the positive 3 to the other side becomes negative. Negative 3 plus I root 5, and negative 3 minus I root 5. Those are my two solutions. And again, if you plug those back into here, they actually would work. If you could even do it, you could do substitution and do it. Isn't that weird? That if I did this, negative 3 minus I root 5 squared plus 6 times negative 3 minus I root 5 plus 14 equals 0. So I don't typically do this, but I'm going to do this right now for you guys just so you can see it. Because I think it's bizarro that all of this stuff just cancels out, but it really does. So when I say square, that means multiply by itself. So I'm going to do that here. So negative 3 minus I root 5, right? That's what squared means. So negative 3 times negative 3 is 9. Inside right here is positive 3I root 5. Outside is positive 3I root 5. So that becomes positive 6I root 5. Awesome. Now over here, I distribute 6 times negative 3 is negative 18. And 6 times negative I root 5 is negative 6I root 5. And some little ding, 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 dings just went off, right? Plus 14. Good deal. So now I'm going to go ahead here, and 6I root 5 and negative 6I root 5 cancel out. And something just happened. Something just happened on my thing that I didn't get. 6I root 5 minus 6I root 5 should cancel. 9 minus 18 should be negative 9. Negative 9 plus 14 is 5. And 5 doesn't equal 0. So I had a little glitch. So let's look back here really quickly and see where my glitch might have happened. So x squared plus 6x plus 9, x plus 3 squared. I move the 14 to the other side. It's negative 14, add 9, negative 5. Subtract the 3. Negative 3 minus I root 5. Oh, it's right here. Right here. Oh my gosh. I apologize, everybody. I did first times first, and I did outsides, and I did insides, and I never did last. So I need to do that negative I root 5 times negative I root 5, and that's a negative times negative is positive. So I have I squared, right? Times the square root of 5, and times the square root of 5. And the square root of 5 times square root of 5 is 5. I squared is negative 1. So negative 1 times negative 5 is negative 5. Now, negative 5 plus the 5 that I had left over does actually 0 equals 0. Whoosh. Okay, so that's one of the things that you definitely want to do is sometimes you'll get stuff that doesn't make sense to you and you'll be like, what the heck did I do? So all I had to do was go back from the beginning and kind of look through my process and go, where was it that I messed up? And I got so excited to show you that these things canceled out that I forgot to do the entire foil on that one. But instead of freaking out, I took my time, I went back, I looked at the stuff, and we got it. Okay. So I don't think there's anything else in that unit. So again, this Mr. Bell's, this was how do we deal with quadratics or other types of equations that end up with square rooting negatives, and how do we solve those things? How do we go beyond what we were able to do before, where we just said, hey, it just doesn't work. Let's talk about what are possibilities. So in mathematics, we created this thing called I, which represents the square root of a -1. And now once we've done that, we've got to prove that it still holds true mathematically, adding, subtracting, multiplying, dividing, all the way through. And then how does it apply with certain equations? So hopefully that was good for you guys. Again, remember, you can stop, pause, rewind this video anytime that you need. And this goes with section P-6 on complex numbers. So far so good. Hope everybody's staying healthy. Again, this video was created in 2020, second trimester for Precalc, because we are currently in a remote learning situation, and I'm out because I'm sick. Talk to you guys later.